Hello, this is Jose Cepeda, and this is walkthrough video quiz number 3. And we were asked to solve for V sub O in the circuit below. And the way that I approached this circuit was to first identify and use the Thevenin theorem. And the first thing that I noticed was then I can calculate for my Thevenin resistance. And the way that I did that was I first noticed this circuits being in series. Then I added them up, yielding a resistor in parallel. Then I apply the resistor in parallel equation assuming 2 resistors. Then that will give me 20 resistors times 5 resistors over 20 plus 5, and that will yield 4 resistor plus 1. The Thevenin resistance would be 5 resistor ohm. And then the second thing that I did was identify that if I have a current going through a mesh, that is the current source. And I see that I have a 3 amp current going through this closed loop, so the current is 3 amp. And then per Ohm's law, if I multiply voltage equals current times resistance, that will yield a voltage. And 3 times 16 was 48. Therefore, that will yield a voltage source of 48 amps. And that's exactly what I did over here. And that will allow me to simplify my circuit. And that's how I redraw my circuit with my 48 volt, and then a open circuit between terminals A and B, and that's also equal to the Thevenin voltage. Then after that I did a mesh approach to solve for my current, and per passive sign convention, if my current is entering a negative terminal, therefore it will be a negative voltage. And then I start collecting all my my resistance, which equal to 25 I, and then this current enter a positive terminal, therefore it's positive, everything equal to 0. Then I continue to solve for that current, which yield 1.44 amp. And then basically, since it's the same current going through, I follow the same principle to solve for the next open circuit loop. And since the current enter a negative terminal, that will yield negative 12 plus 5I. And since the current is open and going through an open circuit, there is really no current going through the 1 ohm resistor, so that will yield equal to 0. And basically we're trying to solve for the Thevenin voltage, and since the current was entering a positive terminal, V plus V sub TH, and then I started solving for the Thevenin voltage, and since we already had a known current, I just inputted that known variable into my equation to yield a Thevenin voltage of 4.8 volts. Then I follow and continue to finally simplify and establish my Thevenin circuit. And in this case, since we already knew our Thevenin resistance of 5 ohms and a Thevenin voltage of 4.8, we can just redraw our simplified circuit this way, and we can finally add our load resistance into it. And the way that I approached this was through voltage division, because through voltage division rule we can find a total voltage division through a series of resistors, and that they're equally divided. They were equally and proportionally divided. And since we already know our Thevenin voltage, the last remaining unknown variable will be V sub O. And then we're just starting by knowing our formula, inputting our known variables, and solving for V sub O, which yield of voltage crossing through terminals A and B through my load resistor of 3.2 volts. And that's basically how I approach this problem. Thank you.